Hi everyone. This is an example of a mole-to-mole style of stoichiometry problem. Here we go. A 0.500 mole sample of carbon dioxide gas is produced during the combustion of propane, which is C3H8. How many moles of oxygen were used to produce the sample of carbon dioxide gas? Can't stress enough that every time we approach a stoichiometry problem, we're going to follow these same 4 steps. And the first step is balance the equation, interpret the question. When we have to balance the equation, we're on the lookout for key words in the sentences that are going to help us wrap our head around what the reaction is. We're going to see a lot of the time reacts with, neutralizes, is combined with, is placed into, mixes with, combusted, or produced. Let's look at this again. Let's read this question focusing on these key words. A 0.500 mole sample of carbon dioxide gas is produced. Oh, the products come after the arrow. During the combustion of propane. Oh, what are we going to do? It's the combustion of propane. Think about that, okay? An alternative strategy is to skip the number. As we go through the unit, we're going to encounter more and more values, so it becomes an increasingly useful strategy to reread the problem while skipping the numbers. Here, in the beginning, there's only one number. It's not that helpful. However, a sample of carbon dioxide gas is produced during the combustion of propane. We need to do what we need to do to understand what the question is telling us about the reaction in order to write it out and balance it. Here, it's saying it's the combustion of propane. I've left off the states. There's really a narrow range of times where the states are actually going to make a difference. It's if a question specifically asks about the precipitate, or sometimes it might even ask us about a gas. Here, we're getting told that the carbon dioxide was a gas. It doesn't affect our work. And propane is a gas too. Doesn't matter. I don't need to spend my time deciding on states unless especially it's about a precipitate. Continuing, now I need to balance this equation. It's a hydrocarbon combustion. 3 carbons, 8 hydrogens, 4 times 2 is 8. Remember that we need the total number of oxygens here on the right-hand side to balance these ones. This is 6 oxygens and another 4. We have a total of 10 oxygens here on the right-hand side. So we need a 5 right here to balance those oxygens. We have a balanced chemical equation now. We need to move on with interpreting the question. 0.500 mole sample of carbon dioxide. This number is about the carbon dioxide, so I'm going to write it underneath the carbon dioxide. I'm going to put the number itself, the units, but also the label for that value underneath the appropriate chemical. It says moles, so I'm putting N, it's 0.500 moles. I put the N because it's the moles. I put it under the carbon dioxide because it goes with it. As I continue reading, how many moles of oxygen were used? I'm trying to find the moles, so I'm switching colors. How many moles of oxygen? So under the oxygen, I'm going to put an N and a question mark. How many moles, N question mark, under the oxygen? The chemical that we're solving for is the required. We're required to find something out about it. And this 0.500 was given by the question. The carbon dioxide is the G. All of this, balancing the equation, doing some labeling in our minds or down on the paper is step 1. balance the equation, and interpret the question. From there, it's going to go pretty fast. Find moles. Find moles by reading or by doing mass over molar mass. Here, no brainer. There it is. Found it. Found the moles, 0.500 by reading. Found it. Next step, multiply by R over G. R, the number in the balanced equation of what you're looking for. Here it is. Wherever that question mark is, that's the R. Ooh, it's balanced with a 5. The R here is 5. This is the chemical R because it's what we were looking for. We were required to find something out about the oxygen. It has a coefficient, its balancing number 5. Over G, here's the given. It was in the question given to us, and the carbon dioxide is balanced with a 3. That's going to give us the moles. Here we're looking for the moles, so our last step is we're just going to stop. We can take our time. We could probably do this math in our head. Let's take our time though. 0.5 times the mole ratio, R over G, 5 over 3, gives an answer of 0.833333. Those 3's are repeating. I go back to the question and look at the number. It has 3 significant digits, so my final answer must also have 3 significant digits. .833. Now we need units. We found the moles. In the beginning here, a lot of our time and energy is going to be spent on interpreting the question and deciding what's given to us, what's required to us. This labeling system really comes in handy. The calculations themselves aren't amazing. However, watch those significant digits and the units. This particular style of question is called mole-to-mole stoichiometry because we had moles given to us for one chemical and we were looking for the moles of another chemical. And I hope that helps.